Okay, so let's do an analysis of that pendulum we saw a little while ago, using this local linearization type approach. So let's see. So here's the equations for the pendulum. So our F is just y, and our G is this minus omega squared sine x minus gamma y dealy. And so let's see. So the Jacobian for this guy is going to be 0 minus omega squared cosine x 1 minus gamma. And so if we look at the undamped case, then the undamped case here means that gamma is equal to 0. So in that case, we're going to be looking at the matrix 0 minus omega squared cosine x, 1, and 0. Okay, so let's see. If we look at the critical point that looks like 0, 0. And so this will actually be the same for any even multiple of pi. We have the determinant of j minus lambda I is going to be I forgot to write down the linearization. Hold on. Whoops. So at this point, the linearization is xy prime equals 0 minus omega squared 1, 0 times xy. Okay, and so then the determinant j minus lambda I is going to be, we've got a minus lambda here, minus omega squared 1 minus lambda, and that gives us lambda squared plus omega squared. So we get eigenvalues of plus and minus I omega. And so it's purely imaginary. So our critical point is going to be a center. And then if we look at a critical point which is an odd multiple of pi, then the linearization here is going to be 0 omega squared 1, 0. And when we go to find the eigenvalues, the only difference is that this time we have positive omega squared. And so we have lambda squared minus omega squared, which by difference of squares formula tells us that omega is plus or minus omega. And so one of those is going to be positive and the other one's going to be negative. So we have roots with different signs. So that means we're going to be having a saddle. So the odd ones behave like saddles. So let's see if we have, let's draw some of these here. So we'll have 0 and minus pi, minus 2 pi, minus 3 pi, pi 2 pi, 3 pi. Then let's see. So what's going to happen is these odd ones are like saddles. And let's see, so if we're inside, then we've got some kind of a periodic trajectory, something that looks like this. And so that's if the displacement and the displacement and velocity that we begin with are not too far away from the critical point. However, if we start higher, like up here somewhere, that corresponds to beginning with a much larger initial velocity. And so then what we see is something that looks like this. And so this is the pendulum spinning. And then you can see the velocity decreases in magnitude every time we get to one of those odd multiples of pi. But it just keeps going around and around, just slowing down a little bit as it passes right over the top. And then in order to see like which direction all this stuff is going, we can just evaluate. So look at, say, if we do above an even multiple of pi, then what we get is 1 minus omega squared minus gamma squared. And so that's a vector that's going over 1 and then down somewhat. So that's telling us that we have something that goes down 1 over and to the right, like this. So that's telling us that the direction of flow is going clockwise with all of these things. There we go. Okay, so that's a picture of what it looks like in the undamped situation.